Hi, welcome to SP 8.2 Probability. This is actually very similar to the grade 7 outcome in probability, where we talked about combining independent events. And so independent means two events that really have nothing to do with one another. So if I roll a die and I get 6, that really doesn't have any bearing on what the next roll is going to be. So independent events have nothing to do with each other. So we need to look at different situations in our community or in our family where probability is involved. Usually it means like poker at Christmas. Explain the relationship between two independent events and the probability of each event separately. So we need to know how to make just basic probabilities and then what to do if they have to happen independently. Test your predictions, measure your experiments, create and solve problems. So just a quick review, what is probability? It's basically expressed as a fraction, and then usually that is converted into a percent. So on your numerator, the top of the fraction, this is the number of ways that it can happen, and the denominator, the bottom, is the number of possible outcomes. So for example, if I roll a die, I can only get one number, but the total possible outcomes, there were 6 different options that I could have. And then because we remember that a fraction bar means divide, you can use a calculator and say 1 divided by 6, which gives you about 17%. So if you're playing with dice, you should know that you have a 17% chance of rolling whatever it is you want to roll. The difference between independent events, which is what we're talking about in this unit, and dependent events, which is probably what will happen next year in grade 9. Independent means that those two events occur in a sequence, one after another, and the outcome of one does not affect the outcome of the other. Whereas dependent events, the outcome does change the next event. For example, if you have a bag of marbles and you draw one marble out of it, so instead of the odds being out of 3 on the first draw, the next time they're out of 2 because you've removed a marble. So in dependent events, the odds change every time you do part of your experiment. Okay, so examples of independent events where it does not affect the next event: flipping a coin, rolling a die, being left-handed, and owning a dog. Those two have nothing to do with one another. Eating popcorn and singing Broadway show tunes. It could happen. Okay, so let's try a little math with this. The first step that you want to do is figure out the probability of just that single event. So let's look at our spinner, and we have red, blue, green, and yellow. So let's make fractions for each of these so we can tell what the probability is. So there are 2 red possible out of a total of 6 spaces. Same with blue, it's 2 out of 6. Green, there's only 1. And yellow, there's only 1. These options should all add up to 6, and they do. Okay, and then if you wanted to express those in a fraction, you could use your fraction bar that means divide and figure those all out, and it would add up to 100%. Okay, let's look at the dice on the bottom there. I've drawn out the sample space here of a die, just showing what each face shows and what your options are for possible outcomes. And so every option on a die is 1 out of 6. So if your question said, what are the odds of spinning blue and rolling a 6? You need to spin blue and you need to roll a 6 to win $1 million. What are the odds of that happening? Well, let's look at our independent probability for blue is 2 out of 6, and rolling a 6 on a die is 1 out of 6. These two things have to happen together, and so what this means is that you need to multiply. When you have independent events, Same with dependent events. If they're happening in sequence, anytime you have a sequence and the word and is involved, that means multiply. So I want to roll blue on the spinner, and I want to roll a 1. So because and is involved, we need to multiply those odds. So 1 out of 6 times 2 out of 6. When you're multiplying fractions, you just multiply straight across. 1 times 2 is 2, and 6 times 6 is 36, and we can reduce that down to 1 out of 18. Okay, looking at this little bag of marbles, what is the probability of drawing red 3 times in a row? Now we're going to replace that marble every time, so it's the same odds, and so one event does not affect the other. We're still talking about independent events. The odds of getting red, well, there's 3 of them in the bag out of a total of 5. The odds of getting blue is 2 out of 5. So we'll start with that, just our basic odds. And then if we want to draw red 3 times in a row, we're looking at this odds 3 times. We want to draw red, which is 3 out of 5, and we want to draw red, again 3 out of 5, and we want to draw red. So 3/5 times 3/5 times 3/5. And as I just explained, in multiplication, we just multiply straight across. 3 times 3 is 9, times 3 is 27. 5 times 5 is 25, times 5 is 125. So not really great odds of drawing red 3 times in a row. So let's look down at the bottom. This is a big clue when you're doing probability, the difference between and or. So we've talked about and, it means that you need to multiply, because those 2 events have to happen. We need them both. But if the question happens to say or, if this marble bag, for example, said, what is the odd of drawing red or blue? Well, the odds of drawing red is 3/5, and the odds of drawing blue is 2/5. And because you've said or, that means it doesn't really matter which one or the other, doesn't matter. And so in this case, we can add those odds and say, well, the odds of drawing either one of those colors is 100%, because that's all that's in there. All right, let's try a question here. A die is rolled twice. Find each probability. So what are the odds of rolling a 2 and then, right, and then a 3? So they've used the dot as their multiplication sign. Sometimes you'll see that. We usually use brackets or even just a times symbol when we're using fractions, but they've got a dot, which is all good. 1 times 1 is 1, 6 times 6 is 36. In the next question, the odds, the probability, that's the capital P there, of getting 2 of the same number. So this one's kind of fun. In the first example, it doesn't matter what you get, so it's 6 out of 6. Any number will do. But then in the next roll, you have to get that particular number. So let's say in this case it doesn't matter, but in this case now you've rolled a 3 and now you have to roll a 3 because it says you have to get the same number. So the odds of rolling a 3 are 1 out of 6. And then you multiply straight across. 6 times 1 is 6. 6 times 6 is 36. This reduces down. You're dividing by 6. What you do to the top, you must do to the bottom. And that gives you 1/6. And like I said, if you wanted to use your calculator and find the odds of that, we just figured that out. It was 17%.